up-to-date way of configuring their radios so that they work at optimally. They have a ground technician and a climber who is on the tower. Basically, the way they configure the radio settings is that the guy on the ground will literally call out any changes to the radios that need to be made. He'll call it out, the technician on the tower will make the changes, then they'll both wait until the computer returns some kind of feedback as to what parameters still need to be adjusted. So this is kind of, it's a long process, it's very odd. There's a lot of yelling and it's very loud. So unfortunately, this is very cost ineffective, it's very expensive, and it's not the best way to do things. So we're considering a way to eliminate one of these technicians. So what we did this semester is using off-the-shelf components. We build a dongle prototype, all centered on the microcontroller that TI makes, the MSP430 Launchpad. We stacked it along with a Emco Bluetooth Low Energy booster pack. We chose Bluetooth over Wi-Fi just because the power consumption was lower and the demands for the distance wasn't great. There's other packs that will be considered later, but I'll talk about that later. So basically, what the Bluetooth does is it connects via any Apple device or mobile device to what we have currently now is a computer-generated radio emulator. We have the purpose of using an Apple platform is its popularity and just accessibility. You know, it was a more popular choice to run on. We have basically the way that our purpose also was to make this we wanted to make this more user friendly, and the way we do this is by running on the iOS platform. You know, we'll be able to have easy to read data from the radio. We'll also be able to connect a lot easier than any other platform. And finally, we'll be able to configure and change any parameters very easily without much effort. So with this system, we believe that a single highly trained or technically trained climber will be sufficient, and we can do away with the cost and the need for a second technician on the ground. Going on to second semester, we're looking to power the dongle using a battery stack. We're also considering possibly doing power over Ethernet to power it, and we'll definitely be looking and exploring into PCB design next semester. Is there any questions?
So the guy up in the tower has his phone and he reads off the parameters of the radio that he's trying to tune. That's what the end goal is.
Yes,
is that correct?
Basically. Unfortunately, we still have the purpose of the guy climbing up there. Exalt has decided not to use motorized radios just for the sake of the maintenance and the cost. Their biggest goal is to make this something affordable, something highly accessible to to its customers, and you don't want to mark up the price. So basically, it is just getting rid of that second guy that we can eliminate with this system.
And why can't he do that today? I'm missing that.
Why can't we do that
He's
today?
your picture shows he has a laptop.
Oh, there still requires some interaction between the two guys. They're yelling at each other.
The way it's currently set up is the guy on the ground is able to plug into the Ethernet cable that runs down the tower and is able to read the information. The climber on the tower does not want to carry up a laptop, which is the reason why we're going to a mobile device, because most climbers already have their phone up there, so they would be able to interface with the phone versus having to take an entire laptop or have the guy on the ground reading the laptop for that information.
Alright, so you guys decided to use Bluetooth. Is there any security concern with encryption? We need to encrypt data.
We went with the Emco board, which had built-in security on it already. The Bluetooth does not why we decided to go with Bluetooth versus relaying information from the laptop that's already on the ground up to the climber on the tower is sometimes